Thank you for tuning in. Our next presenter is Leslie Klein, President and CEO of CCOM Satellite Systems. Mr. Klein, you may begin.
Thank you very much. Good morning and Happy New Year to everyone. Thank you for joining the CCOM presentation today. And I will launch into my presentation. Hope you guys, everybody who is there can see it. I'll just move to the next slide, slide number 2. Describe the company. We have been in business about 24 years, publicly traded on the Toronto Venture Exchange and on the OTC, on the CYSNF. The company was established in 1997. It's one of the largest common depose mobile VSAT manufacturers in the world. We are developing also some new revolutionary antenna technology that I will describe to you shortly. The company has 34 employees. It's trading on the Toronto and the OTC exchanges. The last closing price of August on this slide shows a closing price of $2.92 Canadian. The company pays dividends, and the market cap of the company at that point was about $112 million, $113 million dollars Canadian. The next slide. Oops. The company has delivered over 8,500 systems, antenna systems. These are antennas that sit on top of a vehicle, and you can drive them anywhere in the world. Push a button, and within a few minutes, you locate any satellite anywhere where you have a service arranged with, and deliver high-speed broadband internet into a vehicle or any moving structure. So this makes it possible for a lot of companies that have no access to internet to get internet connectivity. The company is represented in 106 countries with over 500 active dealers. We are only based in Ottawa, Canada. We have no other offices. We keep the company relatively small and relatively efficient. We don't manufacture anything. Everything is outsourced and delivered to us. We have over 33 models of antenna systems operating with different modems and different frequencies. The company is debt-free. It has a working capital of about $22 million and pays dividends. It has paid out over $15 million in dividends since as of July of 2020 and continues to remain profitable. We are not looking for any funding or financing. We are just developing products that will hopefully change the sales aspect of the company to a totally different organization based on the new technology that's coming along this and next year. The vertical markets that the company services is very large, as you can see from this slide here. From government to military to emergency disaster management, banks, telephone companies for cellular backhaul, hospitals, schools, mining companies, and very large oil and gas companies around the world. For example, Halliburton is one of the largest oil and gas company users of our antennas. They have over 1,000 antennas deployed with huge network systems that is delivering the connectivity to them around the world. This slide shows a distribution of antenna systems around the world. Interestingly enough, you can see how many there are in North America and in Europe, as well as in New Zealand. In New Zealand, every fire truck has one of our antennas on it for disaster management due to fires and emergencies, earthquakes. A lot of the Northern European antenna system distribution is for oil and gas, and of course a lot of it is also in the United States and Mexico. Next slide. This slide essentially shows a product lineup of all the antenna systems. So we have driverways, which we sit on top of a vehicle. We have flyaways, which can be put together very rapidly and transported in light cases. And then we have another set of antennas, which are fixed mobile antennas that are permanently attached to a roof of a building and track satellites and/or are able to locate multiple satellites at the press of a button. The controller technology that we developed is key to all of this, and they use pretty much the same controller. CCOM has designed a new product last year, which is on this slide here. It's a MEMPAC, and as you can see, it's about 20 kilos, 24 kilos, and with the press of a button, you can locate a satellite within 30 seconds. With this product, within 5 minutes, you can put it together without any tools. It's carbon fiber, very light, and we have sold over 250 of these antennas already in the last year and this year. In the first quarter of this year, we have received another order for 100 of these units for disaster management and cellular backhaul. The next slide shows you how these antennas are utilized. You can see that they're used in disaster management when in case of earthquakes, slides, mudslides, and destruction of cell towers. So these become small cell tower cellular backhaul antennas that deliver cellular connectivity in case a cell tower is destroyed. The following number of slides I'll go through quickly just shows you vertical applications of the use of these antennas around the world. You can see oil and gas applications from China to Libya to Russia and United States. The following slide is a slide of satellite news gathering for television broadcasting. A lot of TV stations broadcast from remote locations. They need connectivity. Our antenna allows it to deliver high-speed internet and high-speed broadband data and video at the press of a button. So you don't have to know anything about satellites. You can just arrive, push a button. Within a few minutes, you are connected, and then you can do your business pretty much the same way as you would do it from any downtown office or from your home office. This one shows an emergency response application. You can see the disaster recovery, for example, of SoftBank there in Japan when there was a tsunami, the Fukushima disaster where they lost up to 400 cell towers. CCOM replaced those cell towers with mobile antennas within a couple of weeks, a lot of them, and within a month, the rest of them. And there's a fire department in Japan that shows also the use of these antennas on their fire trucks. This one is a telehealth application, a lot of health-related applications from mobile surgeries to breast cancer screening to telemedicine applications to ambulances in Siberia. This one is a military application. You can see a lot of different uses by U.S. military, by the Polish military, by the Russian police, by NATO forces, by U.S. forward operational forces, and again, it's a versatile product. It can be used for all kinds of applications, including military applications. Telecom, cellular backhaul is very large in using these applications, and these are just some of the worldwide uses of cellular backhaul, using these antennas to replace cell towers or augment private cellular networks as required. And then we have mobile offices. Some of them here are showing mobile applications, e-government uses for printing of passports and IDs, to mobile education and mobile youth services around the world. Again, our antennas are deployed in these applications in South Africa and Argentina, where they are used by the government to provide services to people in remote locations. So let's just see. Next slide. And mobile banks are something that are a very large use of antennas also. They actually become mobile ATM machines, and they're used for dispensing cash or charging cell phones for use of as payment. And again, these are applications where connectivity does not exist, terrestrial connectivity does not exist, and satellite is the only way to go. Many mobile banks around the world using these antennas for practical purposes. And we believe that there's quite a number of opportunities, especially in India, for example, where mobile banks do not exist, neither physical bank structures exist. So we are working on a number of opportunities where these type of applications could generate extra revenue for the company by opening up new markets. The next big thing that CCOM is involved in is the antenna systems that are being presently utilized for geostationary satellites are not going to cut it with the low Earth orbit satellites that are around the world being launched by SpaceX, by OneWeb, by Amazon, and many others like Telesat, Viasat, Inmarsat, Facebook, Hughes, Kepler. They're all looking at low Earth orbit satellites to deliver broadband connectivity around the world to a large number of potential customers. Over 3.5 billion people around the world have no satellite connectivity or no any connectivity for that matter, and they have no internet connection. So these constellations that are being put up by Musk, he has already put up over 1,000, and Amazon is just about to launch quite a number of them. OneWeb has 400 or 500 of these satellites. So CCOM has developed an antenna system to service or potentially use take advantage of the use of these constellations. As you can see on this slide, it's a very small Canadian quarter size antenna element that is a 4x4 transmit receive element that can be put together to create a larger 1064 module, 1000 element antenna. And the modularity of this antenna will make it possible to build as large or as small antennas as required. This antenna will make it possible to track multiple low Earth orbit satellites while stationary or while a vehicle would be moving. The project is based around an intelligent chip technology that CCOM has been designing with the University of Waterloo for the last 4 years. Funding for this is coming from the Canadian government and from CCOM. The University of Waterloo is designing and developing this technology for us. CCOM will own the IP, 100% of the IP of this development, and we are in a process of starting to test this year this technology over a live satellite like a Telesat LEO and GEO satellite. We hope to have some test results published early this year and have a number of antennas manufactured this year with hopefully this production, full production next year, delivering these revolutionary electronically steered antennas that are also conformal, which means that they can be put on the fuselage of an aircraft and can be built into different shapes, as large or as small as required. CCOM has multiple patents on this technology that we have already applied for, and we will be applying for additional patents on the development of this new technology. So the next slide shows you how you build up a small antenna from a small antenna to a large antenna. And the beauty of this antenna is it's very thin. It's a few centimeters thick. It is stationary, so it means that it doesn't move, but it will track multiple satellites simultaneously and electronically, and will make it possible to track low Earth orbit satellites as they're passing overhead, multiple of them at the same time. This slide actually shows you a lab test of a parabolic antenna on the left side, and the two panels, the transmit panel and the receive panel on the right side, how they compare to what exists today and what the future will look like with electronically steered antennas. So these are the elements, the small 4x4 elements that build up these panels, and so we'll be manufacturing the elements and putting them together like Lego to build a larger or a smaller antenna, and we'll be selling these antennas to integrators who will want to create specific applications using these electronically steered antennas. The next slide shows you how this product looks like on a vehicle. This one would show you what it looks like on a train. And this slide shows the product potentially on a fuselage of an aircraft. So you could have multiple antennas. They can be networked together. You could put them in different locations, and because they're conformal, then they fit to the fuselage of an aircraft. You can actually tile them on the fuselage and put them at the best possible location of the aircraft or any other moving device. CICOM has recently joined the HEFPA consortium, which consists of two very large semiconductor manufacturers and a number of universities to develop and design the next generation chipset for the very high frequency V-band antennas, which will be used to replace cell towers through the use of drones. So in this particular picture, you can see a drone flying at a height of about 20 kilometers, covering up to 400-kilometer radius and replacing up to 400 cell towers with one particular drone. And the drone itself will be able to communicate with regular cell phones on the ground, and also the communication structure will be such that people going from one cell tower to an area where there's no cell tower, they would be able to pick up the signal from the drone. The drone will also communicate with the satellite overhead and connect down to the ground through the fiber network to complete the whole circuit. The CICOM patented phased array technology will be utilized in these chipsets that hopefully will be manufactured by the large semiconductor manufacturers. The IP is jointly shared between the companies that are involved in the development of this technology. The funding is coming from the European Space Agency and from the Canadian Space Agency for this development. So there's an interesting video that shows this development, and here on this slide you just see the partners involved in the development of this chipset, so it's mainly Canada and Netherlands. The NXP is a large semiconductor manufacturer in Holland, and Skyworks Solutions in the U.S. and Canada is the other semiconductor manufacturer. So the partners, these are the manufacturers is experienced in radio frequency chipset design, and will be actually manufacturing these products in about 2 years time frame. The product will actually be a next subset of, or a next set of 6G actually, would be a much higher frequency technology than what we have today in 4G and 5G. It will be up to 100 times, 10 to 100 times in reduction of latency as a result of it, and also an increase in speed capability on the cell phones themselves. There is a concept shown here on a link called SoftBank HAPS Mobile Mission Concept. If you have the time, you can click on this link and watch the actual technology, how the drones will be utilized to communicate down to the ground and replace a large number of cell towers, and how this will be covered around the world to deliver high-speed connectivity to areas where there is no cell tower technology or no cell tower capability to install and deploy, and also how this technology will actually work with satellites potentially. This is the end of my presentation. If you have any questions, I'll be happy to respond to them. Let me just see if I can find the questions for the whoa. So there is some questions in here. If the audience is still there, there is one question here from Anthony Marchesi about how is the product, the electronically steered technology that we are developing different or unique from other companies. The other companies that have announced electronically steered products are of different type of technology. Some of them are not modular. In other words, they will not be able to build very small, very inexpensive antennas and combine them into larger products. Others use a completely different technology that that is not similar to ours, which is printed circuit board based, so it makes it possible very easily to manufacture. And the big thing is that most of the antennas so far that have been announced are fixed antennas, which means that they are working with SpaceX and Amazon service, and they are fixed. So it means that they are not designed to track multiple satellites while in motion, and they are designed mainly for the for the consumer marketplace. So we are working towards the commercial marketplace initially, with the opportunity of designing a new antenna using passive components that will be very low cost and will make it possible to also attract the consumer market. But our initial target is mobility and also the attraction of tracking multiple satellites and multiple manufacturers' constellations. So we are not going to be specific to any one particular constellation, but hope to be utilizing all of the constellations that will be available using the technology that we are designing. The next one is by Alan Zuckerman. What is the range price of your various iNet UV-SAT systems to the end user? They range from about $10,000 to $12,000 all the way up to $80,000, depending on the size and depending on the complexity of the system. Sometimes you build the complete turnkey solutions for a customer, which would be more expensive than the regular off-the-shelf product. We have another question here by Alan. What is the current TAM of your addressable market? Contrast that to what becomes the TMM or phased array product if it becomes commercially accepted, and in what time frame. We are presently in the testing process of our first generation antenna. We are developing also in parallel low-cost passive antenna, as I mentioned before. This antenna is essentially going to be tested and verified and approved to operate over commercial satellites as they exist today in low orbit, such as the Telesat Ka-band and the Kepler, for example, antenna. And we will be hopefully producing a number of products by the end of this year, and we expect to be hopefully in production sometimes next year. Okay, let's see who is there else. Again, Alan, how many phased array units we produce? Obviously, we will need to produce millions of these antennas to reduce the overall cost per antenna. And since the modules are very small and they are combined to create a very large antenna, we'll be able to manufacture millions of these, much the same way as printed circuit boards are manufactured for computers. But the market size and the cost and the per antenna size remains to be determined. It's not something that that we have hard numbers for today. And then how much does celestial communication currently cost on an aircraft, and what do you expect your phased array unit to cost on an aircraft? Presently, an aircraft antenna is probably in the range of $150,000 to $200,000 for an aircraft. We obviously will have an antenna that will be significantly less expensive when it's ready to be deployed, but there is a different different process of getting to the aircraft business. You need somebody to install it, support it, maintain it. We will not be in that business, but we'll be happy to sell the antennas to those who will integrate them for aircraft, not only for aircraft, but also UAVs, military applications, and many, many other applications where the weight, the size, and the amount of bandwidth that this antenna will deliver will be significant. For example, on the UAV, if you can reduce the weight of the antenna, present mechanical antenna, from 50 to 50 pounds, let's say, or 100 pounds to 20 or 30 pounds, you have 70 pounds of fuel left that you can use to extend the range of a UAV. So the applications will be tremendous, and also there'll be a lot of IoT type of applications where these tiny little antennas will be able to be used for agricultural applications and many other low bandwidth applications. Are there any other questions? I see, I think this was the last one here. Refresh, let me just see. There is Lawrence. There's a question from, let's just see. Thanks, Brent. Nice feedback, much appreciated. When do we expect to uplist with OTC to OBX or QX, asked by Richard Hentke? That will depend on how well we develop this technology and how soon do we introduce it to the market. And it could happen early, it could happen a little bit later, but there's definitely a potential opportunity to uplist it to a larger exchange and move it up, hopefully get a little bit more visibility than we have today. What are the 1 2 things investors should look for in 2021? It's a question from Bobby from SNN. The 1 or 2 things we will be showing the investors this year is the technology that is being finalized, the performance of it, the actual test over satellite this year, and many interesting things along the line with the same technology. There's a lot of interest from around the world for this technology to be deployed in multiple vertical markets, and we are talking to a very large number of companies who are very interested in acquiring the antennas to build their own vertical market applications with them. How will the power compare between your current parabolic antenna and your next generation modular panels? The question from Lawrence Partington. The power is definitely an issue because we are talking about thousands of integrated circuits, and there is no comparison between the power required. But with every generation of ICs that we are building, we are now into the second generation, the power requirement is cut by half. And so ultimately, it will be something manageable, but of course, it will not be nearly in the same range as a static parabolic antenna, which requires very little power. This one will be constantly powered when it's tracking, and it will require more power, but it will be manageable. And that's one of the trade-offs of the phased array antenna, is that there will be a larger power requirement, but you are definitely gaining on the weight, size, and performance. What is the life of CCOM's antennas? What is the go-to market, and what are the challenges? Is the question from Justin Foster. The life cycle is, unfortunately, the antennas are built very strong because they are used in extreme conditions, from places like Sahara Desert to the northern parts of Canada and Siberia. And so some antennas have been replaced as early as 2 to 3 years because they are leased. For example, oil and gas companies lease them, and they demand that they be thrown out by the lessor and replaced with new ones. Others have been around for 7 or 8 years, but we do cycle them, and then we do sell a lot of new antennas to existing customers. So it is all over the map, but I would say on average 4 to 5 years. Let me see if there's any other questions. I think that's about it. I'll be very happy to answer any questions you may have by email. You can email me if you want. I'll be quite happy to answer any questions you may have. And I thank you very much for your attention. It was a pleasure speaking with every one of you there.
And that concludes this webcast. Thank you.